Hello everyone, we are gonna talk about mole fraction. This is lecture 4 of concentration terms. We'll write mole fraction of a component is defined as mole fraction of a component is defined as the ratio of moles of the component to the moles of to the total moles of all the components to the total moles of all components present in the solution. So mole fraction of a component is defined as ratio of moles of the component to total moles of all components present in the solution. We write mole fraction as xi. This is how we denote mole fraction of ith component. Xi is equal to Ni divided by sigma n. This is important. Here Xi represents mole fraction of ith component. Ni represents number of moles of ith component, whereas sigma n represents total number of moles of all components present in the solution simply. Now we'll move further. We'll write mole fraction is a temperature independent quantity or temperature independent term, because volume term is not involved while defining mole fraction, so it's temperature independent. Also we'll write, suppose we have solute and a solvent present in a solution. We write moles of solute as n solute, whereas moles of solvent as n solvent. We'll write sigma n, sum total moles, is equal to moles of solute plus moles of solvent. Right here, if we have to write mole fraction of solute, we'll write x solute is equal to n solute divided by sigma n. Similarly, for solvent, we'll write x solvent is equal to n solvent divided by sigma n. If we simply add these terms, x solute and x solvent, mole fraction of solute plus mole fraction of solvent, it will come out to be n solute plus n solvent, number of moles of solute plus number of moles of solvent, divided by total moles, which is sigma n. Sigma n is itself n solute plus n solvent, so if we put the value, it will come out to be 1. So we got an important result here, that sum of mole fraction of all the components is equal to 1. Sigma xi is 1. Now we'll solve a problem. An aqueous solution consists of urea with mole fraction of urea 0.1. Find W by W percentage and second molality. Solve by yourself. Now we'll solve it. Here x urea, mole fraction of urea is given as 0.1. We can write it as 1 by 10, right? X urea is basically n urea divided by n urea plus n H2O. H2O because aqueous solution is given, right? So 1 by 10 can be written as 1 divided by 1 plus 9. If we compare LHS to RHS, we can simply identify n urea is 1 whereas n H2O is 9, right? We can simply observe number of moles of urea is 1 whereas number of moles of water is 9 moles. Now here we are given urea NH2CO NH2. The molecular weight of urea, which is solute here, it is 14 plus 2 times 1 plus 12 plus 16 plus 14 plus 2 times 1. It will eventually come out to be 60 gram per mole. So this is the molecular weight of urea, molecular weight of solute. Basically, we will write the weight of solute as 1 multiplied by 60 moles multiplied by molecular weight, which is 60 gram. Also, weight of water here is 9 multiplied by 18 gram per mole, which is molecular weight of water. It will come out to be 162 grams. Now we'll solve the first part, in which we have to find W by W percentage. So W by W percentage is basically weight of solute divided by weight of solution multiplied by 100, right? So weight of solute here is 60, weight of solution here is 60 plus weight of solvent, which is 162, multiplied by 100. On solving, it will come out to be 27% simply. So this will be the answer. Now we'll solve the second part. We have to find the molality, which is moles of solute divided by weight of solvent in kilograms, right? So moles of solute here is 1, which is mole of urea, divided by weight of solvent in kilogram. So for water, which is 162 multiplied by 10 raised to a minus 3, it will come out to be 6.17. So this is the answer. Now a solution is formed by adding MgO in water such that mole fraction of MgO is 0.2. If density of solution is 1 gram per ml, find molarity of solution. Solve by yourself. Now we'll solve it. Here x MgO, mole fraction of MgO is given as 0.2. Density of solution is given as 1 gram per mole, right? 1 gram per ml, right? We have to find the molarity of solution. So we'll simply write x MgO is basically 0.2, which is 2 divided by 10, which can be written as 1 divided by 5. X MgO is basically moles of MgO divided by moles of MgO plus moles of water, right? So it is 1 by 5 can be written as 1 divided by 1 plus 4. If we simply compare LHS to RHS, we can observe moles of MgO is 1 mole and moles of water is 4 moles, right? Simply we'll determine the weight of MgO, which is the solute here. So 1 multiplied by molecular weight of MgO, 40 gram per mole, it will come out to be 40 grams. And for water, 4 multiplied by 18, which is 72 grams. Weight of solvent, basically we'll write weight of solution is equal to weight of solute plus weight of solvent. So weight of solute here is 40 gram and weight of solvent here is 72 grams. So 40 plus 72, it will come out to be 112 grams. Density of solution given here is 1 gram per ml. We'll further solve. We'll basically find the volume of solution. So density is weight divided by volume. Volume can be written as weight divided by density. So volume is weight, which is 112, divided by density, which is 1. It will come out to be 112 ml. So molarity of solution is basically moles of solute divided by volume of solution in liter. Moles of solute, basically moles of MgO. MgO is the solute here. It is 1 divided by volume of solution in liter. So 112 multiplied by 10 raised to a minus 3. On solving, it will come out to be 8.92. So this will simply be the answer. Hope you understand this. Thank you for watching.